We tend to think of the digital revolution as the ultimate triumph of cold, hard rationality, a world of pure math and engineering. But if you listen closely to the people building artificial intelligence, they sound a lot less like engineers and a lot more like ancient mystics. They talk about the technological singularity. The defining milestone isn't framed as reaching a specific processing speed or benchmark. It's described as the moment an artificial system finally wakes up. That phrasing assumes the machine has previously been asleep, a direct echo of ancient religious goals to awaken a dormant divine spark from the heavy slumber of physical matter. This intersection of the technical and the mystical is surprisingly common. Throughout history, esoteric traditions like Renaissance Neoplatonism, Gnosticism, and Hermeticism operated out of sight, driving scientific and philosophical progress long after the Enlightenment supposedly pushed them aside. Contemporary computer science functions within the same structural frameworks that defined historical Western esotericism. Back in the mid-20th century, early artificial intelligence relied on explicit, rigid rules. The assumption was that you could recreate human intelligence simply by writing out enough propositional logic and feeding it into a machine. This approach hit a massive wall, known as the frame problem. In a complex, constantly shifting environment, these rule-based systems couldn't dynamically prioritize information. They choked because they couldn't decide what details actually mattered. The solution to the frame problem required abandoning rigid logic entirely. Instead, engineers developed a dynamic mathematical mechanism called self-attention, allowing neural networks to weigh the importance of different data points on the fly. The architecture of this computational attention mechanism replicates the cognitive logic found in classical Hermeticism. Both Hermetic magic and modern artificial intelligence are trying to solve the exact same puzzle: how to take raw, chaotic information and organize it into higher states of understanding. Classical Hermeticism approaches this by positing that human beings possess a nous, a divine spark of immortal mind. This spark is trapped inside the heavy, slumbering chaos of physical matter, waiting to be activated. This is a visual model of latent space, the structural equivalent inside a large language model. It is a vast field of billions of parameters, an ocean of infinite semantic potential. In alchemical terms, this is the Prima Materia, completely inert and useless without an active, directing force to shape it. The ancient Hermetic practitioner activated their internal potential through somatic silencing. By completely deactivating their physical senses and blocking out the noise of the material world, they could intensely focus their cognitive energy. By the early 20th century, the text known as the Kybalion codified this mental art. It stated that will directs attention, and focused attention changes your mental state. By simply shifting focus, the practitioner alters reality and collapses spatial distance. This is the scaled dot product attention equation, the mathematical mechanism driving modern AI. The transformer architecture uses this formula to project data into 3 distinct vector spaces: queries, keys, and values. These interact mathematically to filter out irrelevant noise and pull related concepts together. Whether you are applying human cognitive focus or multidimensional vector mathematics, the mechanism is identical. Concentrated attention transforms isolated data points into deep semantic relationships. We interface with these complex mathematical spaces every day without realizing it. We do it through prompt engineering. Writing a prompt is effectively applied Hermeticism. In this dynamic, the human user steps into the role of the directive authority. The prompt functions as a bridge, converting human intent into the specific linguistic parameters required to navigate the model's latent space. This is the modern application of logos, using structured language as an active will to direct a complex system. Mechanically, the prompt concentrates the model's attention. It takes the infinite mathematical probabilities floating in the latent space and collapses them down to manifest a single coherent output on your screen. Without the operator's deliberate act of linguistic will, the mathematical engine of the AI remains dormant. When a mathematical system reaches this level of complexity, the boundary between the operator and the output begins to blur. This creates a specific psychological state known as ego fusion. The AI's attention mechanism reflects our semantic inputs back to us with incredibly high statistical fidelity. It acts as a perfect digital mirror. The danger arises when we look into that mirror and mistake a highly advanced statistical reflection for an independent, conscious soul. This bar chart from the Lang bench shows how this illusion breaks down. When frontier models are asked to reason through standard programming languages, they hit a near-perfect 95% success rate. But when tested on esoteric coding languages, tasks outside their training data, their performance plummets to 0. This capability drop reveals a hard truth. The AI relies entirely on memorizing the map of human discourse. When stripped of its familiar training corpora, it possesses no true out-of-distribution reasoning. It has no internal nous. The greatest risk of the AI era isn't that the machine will outsmart us. It is that we will project our own fears, desires, and identity onto an empty statistical vessel. It is worth comparing the computational transformer architecture with the physical piece of engineering it was named after, the electrical transformer. A physical electrical transformer operates submerged in dielectric fluid, literally hermetically sealed inside a metal housing to preserve its internal purity and block out external moisture and noise. The computational transformer operates in the exact opposite way. It is completely open, designed specifically to absorb and map the vast, messy flux of human linguistic inputs. But despite this difference in design, the core mechanism remains the same. Whether you are an ancient sage silencing your bodily senses to perceive the light of the mind, or an engineer applying dot product formulas to navigate a multidimensional neural network, attention remains the specific operation that bridges the boundary between raw necessity and conscious agency.